Next concept, architectural patterns, reference models and reference architecture. Simple concept ma. Here we will see what is architectural pattern and reference model and reference architecture. Now check that if we want to get a software architecture that use reference architecture. Now using reference architecture we are getting a complete software architecture. And how reference architecture will be formed? Yes, if you observe, the input of the reference architectures are reference model and architectural pattern. The basic foundation for the software architecture are the reference models and architectural patterns. Based on these, reference architecture will be built. Based on reference architecture, a final software architecture is going to be built. Now we will see what is called architectural pattern. A architectural pattern is a description of element and relationships together with a set of constraints on how they may be used. So first of all, what is called pattern? A pattern is a rule or a condition or a constraint. Whatever constraint you are going to be apply on your architecture is known as architectural pattern. Or simply we already know an architecture, so a software architecture is a collection of elements or collection of components and the connectors. Now if you observe, what are components? Modules. Modules are nothing but what element you are considering on your project. In previous example, college, we consider college is a major module and departments and library and so on are the sub modules. Architectural pattern will use the constraints we applied on the modules. On the college module, what constraints you can use? For example, a college starts 9 a.m. ends 8 a.m. that is ends 5 p.m. that is a one constraint. College has must and should be with the established laboratories, that is a one constraint. Like that, how many modules are there on your project? Each and every module is going to be implemented with the patterns. That's called an architectural pattern. A pattern can be a thought of set of constraints on an architecture. Just now I said a pattern can be a condition what we applied on the module of your project, and these constraints define a set of family of architecture that satisfy them. Without conditions we can't consider a particular module, and each and every module must and should be specified some constraints. And simple example they are explaining, client server is an architecture. Normally for what purpose we will use client server? For data transmitting. Consider client server is a software project architecture. Now client and server are the modules. Now client module and server module. What constraints we are going to be used here? The constraints here we are applying protocols. Protocols are nothing but policies or rules used to establish a communication between client and the server. Simple. An architectural pattern gives the conditions or constraints whatever we are considering in our project elements. In this example, client and server are the elements, the protocols are the constraints applied on the elements to communicate between these two project element. Next, what is called reference model? A reference model is the division of functionality together with the data flow between the modules. A reference model gives the decomposition of your module and links between that decomposition. Simple division or decomposition between the module. A reference model is the standard decomposition of known problem into a parts and how the data flow is goes between that elements. And for example, the given compilers, DBMS, lot more examples. The best example to get understand, take the compiler. How compiler will works, we already know. Compiler with the 6 parts that are lexical analysis and syntax analysis and semantic analysis and ICG, intermediate code generator, and code optimizer and code generator. Now this is a reference model. Why it is called as a reference model? Reference model will use the decomposition of elements and the data flow between the elements. Simple. Now here, if we consider compiler as a software project, now these all are lex, syntax, semantic and so on, all are modules. The decomposition of compiler totally divided into 6 modules or 6 parts. And the data flow, you already know from the previous semester how the data flow is between these all 6 phases. And DBMS, we already know the architecture of the DBMS. At the top end users are there and the middle end our SQL engines are there or query engines. At the bottom end database is there. Now there, if you observe, 3 parts are there. Now 3 parts, how they are decomposed. Now next, reference architecture. The reference architecture is how reference model is mapped onto software elements and how the data flow between the elements. Simple, reference model will use the modules and the data flow, whatever you are considering for the project. Reference architecture will use the how that elements are converted into a software project elements. Now compiler, if you consider lex, how lex tool is to be considered is an element. Next, syntax, YACC is an syntax analyzer and semantic analyzer. Like that, each and every component, how that are converted as a software elements and the data flow between that software element, that will use the reference architecture. Reference model divides only the functionality. The reference architecture will use the mapping of that functionality into system decomposition. Nothing but data flow between that elements. Next concept, why a software architecture is important. Is the software architecture important? Without architectures, if we built a software project, is there any happening for that? or is they work reliably? Now see, is the software architecture important? There are fundamentally three reasons are given for the importance of software architecture, that are communication among the stakeholders and early design decisions and transferable abstraction of a system. Now first one, architecture is the vehicle for stakeholder communication. Nothing but between the stakeholders the architecture should be transmitted. Why architecture should be communicated with each and every stakeholder? Now who are stakeholders? Stakeholders may be a customer, users and project managers, coders, testers and so on. Nothing but those people involved in the software project, that all are called stakeholders. Once architecture is finalized by the architect, that architecture should be transmitted through the all stakeholders. Simple reason, they will suggest any new modifications or new requirements what they wanted. Once architecture is finalized, I can say that is a blueprint. The blueprint is transmitted to the each and every stakeholder for taking of the suggestions from them. Without transmitting your architecture to the all stakeholders, if you blindly built a software project for your software architecture, that may not be the efficient, because the future requirements may not given by all stakeholders at the time of finalizing of a architecture. They may changes their decisions or new requirements may occur. That's why once you finalize the architecture, that should be communicated for every stakeholder. And architecture manifests the earliest set of design decisions. Nothing but before implementing your project practically, check your decisions on the architecture. If any modifications are there, we can take early decision before implementing practicality of the project. The architecture defines constraints on implementation, and the architecture dictates the organizational structure. Nothing but total overall architecture of the project you can view in the software architecture. The architecture inhibits or enables system quality attributes. Before implementing your project, you can identify quality attributes in your software architecture. So predicting system qualities by studying the architecture, we can identify the quality and poor attributes by studying the software architecture. The architecture makes easier and manage changes before implementation of your project. If you observe architecture, we can identify what are difficulties and what are easy changes we can apply. The architecture helps in evolutionary prototyping. Nothing but the model. Before coming into practicality, we will observe the model. The architecture enables more accurate cost and schedule estimate. In the architecture, the architect gives the how much cost and within how many days your project is going to be complete. We can also analyze that all in the software architecture. These all are early decisions. Early decisions means before implementing project practically, if we take the decisions at the early stage, yes, you can avoid a lot of difficulties. And architecture as transferable, reusable model. The meaning of this one is we can use existing architecture for the future and new projects. The software product lines share a common architecture. This will give suppose take the one project came for your company. That project started implementation. Before started implementation, you can observe same projects are completed in previous or not. If previous project also comes with the same line, we can share or we can use that same existing architecture to build the new project architecture. Systems can be built using large externally developed elements. The reusability will give the system can be easily built. Less is more. It pays to restrict the vocabulary of design alternatives. The architecture will use the less design complexity. Less design complexity. Architecture will reduce the design complexity of the software project. An architecture permits template based environment. Nothing but before entering into practical project implementation, we will work on the blueprint, that is a template based development. An architecture can be the basis for the training. For any new people enter into your organization, if we want to train them on some projects, they will give existing project architecture as a reference models. Using that reference models or reference architectures, they can learn much more for implementation for the future projects. That's why software architecture is very important, especially for building of practical software project.